A very good afternoon to all of you. Today we are going to learn the third case of solving the first order differential equation which yields the complex eigenvalue. For example, solve that y prime equal to the ay, where the a is given by negative half, 1, negative 1, negative 1. Okay, the solutions for this homogeneous system is actually, we assume the solution is actually y, where the y is a vector, consists of y1 and y2. Okay, it assumes that vector y, is in the solution of eigenvector v exponent lambda t, where the lambda is the eigenvalue. So you have the equation 2. So if we differentiate equation 1, you have y prime equal to lambda. Differentiate respect to t, where the v is eigenvector, a constant vector. Then we get lambda v exponent lambda t, equation 3. Okay, if we substitute equation 2 and 3 into the homogeneous system, y prime equal to ay will lead to, the y prime, this one. Okay, put it into here. So we have a left side lambda v exponent lambda t equal to ay, where the y from equation 2. Once we get lambda v exponent lambda t equal to av exponent lambda t, again comes to the homogeneous system, a minus lambda I, because we are in the matrix. Lambda is a constant, so we have to get the lambda multiply the identity matrix I, v, where v is the eigenvector, equal to 0. By assuming the solution 2 here, y is the v exponent lambda t. If we know the eigenvalue, and then we can find the eigenvector from this homogeneous system, a minus lambda I v equal to 0. Then solving the linear system, a minus lambda I v equal to 0. Minus, so this is our a minus lambda I will effects at the main diagonal. Then solving for the eigenvalue and eigenvector, then we can get the solution for the homogeneous system. To find the eigenvalue, we'll let the determinant of the above system equal to 0. Then it takes the product of the main diagonal, which is negative half minus lambda, because the same thing, that's why squared, minus the product of the other diagonal, so minus and negative, so become plus 1. Simplify it. You may solve this one using your scientific calculator, where you obtain 2 is actually the complex root, where the lambda 1 is negative half plus I, lambda 2 is negative half minus I. Step 2, we substitute the first eigenvalue into the homogeneous system, a minus lambda 1 I v1 equal to 0. So because this is a a11 of your matrix A, so minus lambda 1 minus become positive, this will become minus. So same with the element a, 2 here. Simplify negative half plus half, so we come only left negative I, so similar with the element 2 here, it's just left negative I. If we swap row 1 and row 2, row 1 become row 2 become row 1, we'll get this one. And then if we multiply row 1 by negative 1, so the element row 1, column 1 will become positive 1. Row 1, column 2 here become positive I. Then by using suitable row operations, we'll eliminate the elements rows 2, column 1 become 0, where the row operation that we use is actually row 2 minus, this is negative I, row 2 plus I R1. So means your row 1, you multiply with I. You multiply with I, then you have this is I. So I multiply I, this will be negative 1. Then you have here negative I. This is 1. Then we add up these two equations, put into row 2. So I minus I, you have 0. Negative 1 plus 1, you have 0. Hence, we can prove that these two equations is actually reduced to only one equation. Means we have two unknown with one equation. Hence, we have infinite many solutions will be in terms of parameter s. Okay, let's y equal to s, then x will be equal to negative is. So the xy, y is 1s, x is negative is. Hence, v1, by taking s equal to 1, you obtain the v1. Okay, negative I, if you multiply by I, so we have negative I squared, which is 1. So the second row will become I. Hence, the y1 will be your, this is a v1. Multiply exponent, this one is your lambda 1 t. Step 3, substitute the second eigenvalue lambda 2 equal to negative half minus I into the system. A minus lambda 2I v2 equal to 0. We'll use this one. Simplify it, we have I1, negative 1 I. This one cancel. Against if we swap row, so it become row 1 become negative 1 I. Second row is I1. And then we multiply first row by negative 1. It's actually our purpose to get the row 1, column 1 become 1 unit. And then using suitable row operation, we are going to eliminate row 2, column 1 become 0. So mean we have row 2 minus I row 1. So mean first row you multiply by I, so negative I multiply I will be positive 1. And then because it's first row multiplied by I. And then the operation that we use is actually row 2 minus I times row 1. So I times I, you have 0 here. 1 times 1, you have 0. Hence, again, we can see that two unknown with two equations is actually we left to only one equation, which is x minus iy equal to 0. Again, if we let y here equal to s, then x will be equal to is. So x is is, y is 1s. By taking s equal to 1, we get v2 is I1. If you multiply v2 here by I, so you have I squared by negative I. If you multiply by negative I, then I squared is negative 1. So negative again become positive 1. That's why second row will be negative I. Hence y2 will be the v2 here, 1 negative I, multiply exponent lambda 2 t. Lastly, the general solution will be ay1 plus by2, or av1 exponent. This is actually lambda 1t plus bv2 exponent lambda 2t. Okay, and we break the exponent, become exponent negative t over 2 multiply exponent it. The second exponential term also, we break it into exponent negative t over 2 multiply exponent negative it. And then by using the Euler formula, where you have the it will be the cos t plus I sin t. So the EIT, the term EIT can be rewritten as cos t plus I sin t, and the term exponent negative it it become cos t minus I sin t. Which one? Cos t minus I sin t. Okay, and then we'll collect the term. The term, this one is an exponential term. This is an exponential term multiplied with I. Okay, and break it into the constant A and B. Okay, for example, the A term, you take 1 exponent negative t over 2 cos t. So you use to this one. Okay, this will be exponent negative t over 2 I sin t here. And then for the second row, if this term is actually exponent negative t over 2i, here, cos t. And then I multiply I is negative. So it's negative sin t exponent negative t over 2. Okay. And then for the B term, similarly, you have 1 cos t exponent negative t over 2. And then this one is actually negative I exponent negative t over 2 sin t here. Okay, for the second row, okay, this term will reach to here, which is actually negative I exponent negative t over 2 cos t. And then, okay, for negative I times negative I, we have negative 1 sin t. And then if you want the real value solution, it is the solution without the imaginary number. Hence will be A exponent negative t over 2 cos t. And then the second row of the vector is negative sin t. For the B term is B exponent negative t over 2 cos t. I think we got the typo. This should be cos t. This one is a cos t. This is a negative sin t.